Hello and good morning, everybody, and welcome to this new recording, particularly designed for second year mechanical engineering of the ENSEM school. It will be about engines and motors and motion transmission. The purpose is to acquire the suitable vocabulary in English because you'll be able to talk about such things in English depending on the opportunity. I think this subject is at the heart of what you are studying, and therefore I hope you will be motivated to follow what I'm going to talk about. Etymologically speaking, and according to the Merriam-Webster dictionary, this dictionary is an American dictionary. It was compiled and made by an American lexicologist by himself, so it is named after him. As you can see, there are people who are very committed to their own languages, to their own mother tongue, and they have devoted their lives to compile dictionaries. The same thing could be said about Monsieur Littré. Le Littré is a French dictionary written by one man, and it's one of the best. By the way, he was a clerk in a bank, I suppose, and he had this passion for language, and he made a dictionary for himself. So this is a hint to whom it may concern. I know also in Arabic, somebody who was a speaker, presenter at the BBC Arabic section. His name is Mohamed Oujetti, and he prepared and made a very good translation English Arabic dictionary. So this kind of people, make contributions and serve their own nation by obligation, by hard work and selfless hard work. So I would like to talk about engine etymologically. So according to the Merriam-Webster dictionary, the noun engine, which is pronounced engine, stress on the first, it comes from Middle English, engin, from Anglo-French. You know, there were some interactions between the French and the English throughout history. They are neighbors, so the English have occupied the north of France, especially Normandy, and the Normans conquered the south of England for such a long time. So there have been intercultural exchanges between the two cultures, the two languages. So engin from Anglo-French, but the origin of the word comes from Latin. It comes from ingenium, which means natural disposition and talent. Of course, Latin has a big part, a big role in all European languages, and there is no problem in that. Languages borrowing from each other. The point is to be functional. There is no purity in language. No, there is no ethnic purity or in language. There is functionality, which is the best thing, and this is why the English language is thriving nowadays. So ingenium from Latin, which means natural disposition. So it's a talent, it's a gift. It comes from being gifted with intelligence, gifted with skill, and to be able to make things. And from geniere, which means to beget, to give birth to. Um, so you understand. So an engineer is somebody creative. An engine is something created, something man-made. And man-made means it's a tool created by man, um, thanks to a human intelligence, to human ingenuity. So it has been created. So the word dates back to the 13th century. So as you can see, the English language is quite a young language and proud to be. So there is no harm in being a young language, and no special benefit in being an old language. The purpose is to be a good language, a functional language. That's the point. Um, we should not pride ourselves in having an old, a very old language. This is irrelevant. What is relevant is to be functional, practical, useful, um, and doing the purpose. In the beginning, engine has something to do with ingenuity and with evil contrivance, meaning it has something to do with magic or something. All right, people did not know science, so they associated anything with creativity, with evil, and with wile, that is, with wiliness, with foxiness, with mischievous intelligence. The second meaning, an engine is something used to effect of a purpose. In other words, an instrument, a tool, an agent. And you know what makes the difference between humans and animals is exactly this, to be able to use tools. The nearest primates to humans are chimpanzees, and they are the ones who can use some primitive tools to break a nut or something like that, or to use a straw to bring out ants from an ant mound. The second meaning, so the example of the second meaning is mournful and terrible engine of horror and of crime, as Edgar Allan Poe says. So here engine means instrument. Edgar Allan Poe used this example to signify that uses engine as meaning an agent or an instrument. The mournful and terrible engine of horror and crime. The second meaning, B, something that produces a particular and usually desirable result. For example, engines of economic growth. Well, in other words, a tool, but a miraculous and very good tool. Number 3A, a mechanical tool, an instrument or a machine of war. That's exactly because engineering at first was used in the military area. So humans were inventive, were creative of tools, especially for the purpose of war, of life and death. And of course, an engine referred in an obsolete sense to a torture implement, which was also invented. Again, the evil side of invention. Engine can mean machinery in general, equipment, all sorts of equipment. And C, any of various mechanical appliances often used in combination, like a fire engine. Yes, سيارة الإطفاء, it's a fire engine. Well, because it's mobile, because it has pumps, it has water jets, etc. So it's an engine. It's a combination of mechanical appliances for a specific purpose. Now let me move on to the next meaning. An engine is a machine for converting any of various forms of energy into mechanical force and motion. This is a more modern meaning of the word engine. Engine is the motor. It's a motor. It's something which creates motion. It creates movement, which is used to create movement. So it's a machine for converting any of various forms of energy, whether it is gasoline, whether it is petrol, whether it is electricity, or whatever, into a mechanical force and motion. So it's a mechanism or object that serves as an energy source. Black holes may be the engines of quasars. Oh yes, well that's again the engines, the agents. It has the meaning of agent. Black holes are the agents of quasars. Right. Number 5. An engine is a railroad locomotive. So it's a locomotive. قاطرة is an engine. The engine of a train. So it means that. But it's the same thing. It has to do with mechanism that produces movement, and it can move a train. So it's an appropriate meaning. And number 6, a computer software that performs a fundamental function, especially of a larger program. So it has been borrowed into computer science. A software that performs a fundamental function within a larger program. Exactly. So it has this. It's the instrument. It's the trigger of other things, or the central piece of a larger picture. There is the adjective engineless, without an engine. It's an adjective, engineless. And engine, to engine as a verb, is a transitive verb, which is inflected from engined, to engine. يعني مشتقة من كلمة to engine. Engineing. So it started in 1868, and it means to equip with engines, to engine a vehicle, to equip it with an engine. Now, clearly the word engine has something to do with ingenuity, nuity or nuity. You can pronounce it. There are two ways of different pronunciation. So it's a noun, and it died circa 1592, around 1592. Circa, Latin, means around. So this word entered this language, the English language, in 1592. So as you can see, in the 16th century, in the days when Shakespeare lived, the Elizabethan period, and yeah, that's the beginning of technology. Ingenuity means the power of creative imagination. So again, now we have the element of imagination and creativity, to create something that did not exist before, to create something useful for humanity, to use your imagination, to use your skill, to use your intelligence, your creativity. And it also means the skill or cleverness in devising or combining things, in devising, in making, putting together, in combining. So these are the qualities at the root of engineering. These are the gifts that an engineer should have. This is what distinguishes an engineer from an ordinary person. Ingenuity means inventiveness. So an engineer must be inventive, must come out with new ideas, with new solutions. And the second meaning, the property of being ingenious. So the quality of um, uh, being ingenious, it's the cleverness, the aptness of design and contrivance, to be able to put things together. An ingenious device or a contrivance. So ingenuity can name the objective or the object of ingenuity. That is what is produced by ingenuity, and it can have a plural. Ingenuities meaning uh, devices. وبالعربية إبداع، براعة، أداة بارعة، آلة بارعة. يعني مسألة إبداع يعني فكرة أساسية، والبراعة يعني excellence. Both ideas are involved. Now let's move on from engine to engineering. It's a noun and which dates back to the 1720. Notice that a number of English dictionaries give you the date, the etymology of the word, the origin of the word, where does it come from, and when was it first used. I wish we had this in Arabic. It doesn't exist, unfortunately. We have so many Arabic scholars, but they haven't done so. يا ريت لو كانوا عملوا هذا لكان أفيد بالنسبة للغة العربية. So yes, this word entered the English language in 1720, and you must remember that the first schools of engineering began in the 17th century. So this is the early 20th. It was in France where the first school of engineering started. Well, let's admit this to the French people. And the first engineering schools were military, because engineering was meant to have an edge in military matters over the enemy. Engineering means the practical application of science to commerce and industry. Oh, this is very good for meditation. The application of science to commerce or industry. Commerce first and industry second. Isn't that extraordinary? Yeah, so engineering has a lot to do with business, has a lot to do with money making. So industry is just a step towards commerce, and commerce is a step towards money. So engineering is using your creativity, your intelligence, your skill, your inventiveness at the service, is putting them at the service of commerce and of industry. This is very exciting. Engineering is an exciting endeavor. We must admit this. Number two, engineering is a discipline dealing with the art of or science of applying scientific knowledge to practical problems. Yeah, this is an extraordinary definition of engineering. So it's a science and an art. And Mr. William Webster began with art. It's an art. So it has to do with imagination. It has to do with creativity. And that's where art comes in. And it's also a science because it has the discipline, the rigor of sciences. It's a combination. It's the application of science, actually. It's the use of science by an artist and applying scientific knowledge to practical problems. As I've always said, an engineer is a problem solver. He's a practical person. He's a savior of himself and a savior of humanity. So the application of scientific knowledge to practical problems, the activities or function of an engineer. Yeah, it's the job of an engineer. It's the occupation of an engineer. Engineering is what an engineer does. It's also the application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful for people. Yeah. Yes, an engineer is a Samaritan. An engineer is a selfless person. helping humanity solve its problems. So we must be thankful to the engineer because he uses scientific knowledge, particularly mathematics, the properties of matter, as we have seen in the previous chapter, um, and the sources of energy as well in nature, which are made useful to people. Engineering is a room on a ship in which the engine is located. Well, in the old ships, maybe still in the modern ships as well. It's a special room somewhere where the machines are operated. So in a submarine as well, as you can see in the films. Engineering is calculated manipulation or direction as of behavior. Social engineering. We can talk about social engineering. What does social engineering, for example? It means the manipulation or direction or guiding of society in a certain direction. There is also genetic engineering, manipulating, changing, transforming in order to achieve results. Well, the same original root. An engineer is therefore a noun pronounced engineer. Look at the stress. There's a weak stress at the beginning and a major stress on the last syllable. Etymologically, it comes from Middle English, sorry. It comes from Middle English, ingenieur. دونك ما خصناش نسخروا من الناس اللي تيقولوا لا جونيور. كاين الأصل الكلمة هو ingenieur. I'm just joking. From Anglo-French, from engine, to create an engine, to devise and construct, which comes from engine, and it dates back to the 14th century. This is extraordinary. I mean, to delve back in history, to see where words come from. And I hope this will have an effect, that you will remember these things related to your title and your occupation. So an engineer, as a first meaning, is a member of a military group devoted to engineering work. شو بنقولوا في الجيش تنقولوا في رق الهندسة, le génie militaire. It has something to do with the military engineering, because the military have to find solutions to technical problems to be able to win wars. An obsolete meaning, a crafty schemer. An engineer is a crafty schemer. شو واحد حرايمي is an engineer. He's a plotter. متآمر is an engineer. المؤامرة تحتاج إلى هندسة. Number 3, an engineer is a designer or a builder of engines. That's a very suitable thing, suitable meaning. And B, a person who is trained in or follows as a profession a branch of engineering. And finally, a person who carries through an enterprise by skillful or artful contrivance, which means you don't need to be an engineer to do some engineering, or to be an engineer. When you follow, you carry out, you carry through an enterprise by skillful or artful contrivance, you are an engineer. Of course, the training in an engineering school will help a lot in any engineering undertakings. And number 4, an engineer is a person who runs or supervises an engine or an apparatus. Yes, ce qu'on appelle ici technicien, in the United States they call them engineer as well. So the borderline between engineer and technician is blurred, is removed, because an engineer is someone who supervises a machine. and who runs it, is skillful at that, he has a certain knowledge of engineering, and therefore he does so. And many engineers in the full title do just jobs of supervision and running of engines. الآن أريد أن أتحدث عن المهندس بالعربية، ولا بد ما نشوف هذه الكلمة هذه لأنها لا تشبه الكلمة العجمية أو يعني اللاتينية. فعل هندسة، هندسة يهندس هندسة فهو مهندس، والمفعول به مهندس. هندس الشخص البناء وغيره، إذا نفس المعنى ديال الهندسة يعني صممه وغيره وغير من شكله ليجعله أكثر فائدة ونفعية ومنفعة للناس. هندزه بالزاي، بحرف الزاي، يعني المهندس كذلك هي صحيحة، ما خصناش نضحكوا الناس اللي يقولوا المهندس، لأن الأصل في الكلمة كان فيه الزاي. صممه وأنشأه على أسس علمية. وبالنسبة للسان العرب، لقاموس لسان العرب، هندس الهندس من أسماء الأسد. الهندس من أسماء الأسد. نعم، أنتم أسود أليس كذلك؟ هناك شيء من الأسودية في الهندسة. leadership، لعلها leadership، ولعلها الجرأة. وأسد هندس أي أسد جريء. وفعلا الهندسة والمقاولات تحتاج كثير من الجرأة. الهزبر هو الأسد. الهزبر هزبر هندس، والمهندس المقدر لمجاري المياه. ربما الأصل في الكلمة بالنسبة للعرب كانت في الهندسة، هندسة تصميم مجاري المياه، يعني كيسميوها جيني سيفيل، الهندسة المدنية في هندسة مجاري المياه والقني، يعني القنوات، احتقارها وتحديد ممراتها حيث تحفر. يعني الهندسة بالنسبة للعرب كانت مدنية في الأصل. وهو مشتق من الهنداز، وهي فارسية أصلها أونداز. إذن كما قلت سابقا، ليس عيبا أن تأخذ لغة ما كلمات من لغات أخرى. هذا شيء جاري به العمل، وهذا شيء محمود وشيء مستحسن. فليس هناك لغة صفية العرق أو صافية العرق، لا، لغات عادية، لغات عالمية، لغة إنسانية، ما فيها التشعيب ناخذ مفردات من هذه اللغة ولا من ذاك اللغة. بالعكس، هذا يزيد في غناها. الجرامر كتبقى هي، ولكن المصطلحات والمفردات تأتي وتذهب، ونستلف ونعير، نستعير ونعير، فهذا لا عيب فيه. قوله آوى كذا بالأصل في القاموس آبى، وهما بنفس المعنى. فصيرت الزاي سينا لأنه ليس في شيء من كلام العرب، يعني مثل لك تغير النطق ديالها وتردها، تعربها وتردها عربية، ما فيش مشكل. ليس في شيء من كلام العرب زاي بعد الدال. والاسم الهندسة، ويقال فلان هندوس، لا علاقة به إخواننا في الهند. هندوس، فلان هندوس هذا الأمر، يعني هو الذي يستطيع أن يحله. وهم هنادسة، مهندسون، كلك تقول هنادسة، وهم هنادسة هذا الأمر، يعني مهندسوه أي العلماء به. إذن هنا يأتي علاقة الهندسة بالعلم، يعني الهندسة هي تطبيق العلم. ورجل هندوس إذا كان جيد النظر مجربا. وما أروع هذا التعبير، لأن قوة النظر وقوة الملاحظة وكذلك التجريب because engineering is is applied science. Now I would like to talk about automobiles and their engines. Now, isn't the automobile the epitome of ingenuity? It's one of the greatest inventions that humanity has come to the point that that we could describe our age that has started from the 19th century, from the 20th century, and goes on into the 20th as the age of the automobile. It's a great invention. It's one of the greatest services to humanity, I would say. The purpose of the car is to transport both people and materials faster than any train or wagon. Before automobiles, we used to rely on animals, on donkeys and mules and horses. And of course, these animals are limited. Of course, we used ships over the sea, but on land, it was difficult to transport people and materials. The car is built to be convenient and comfortable, as well as much smaller than some gigantic train or bulky wagon. Oh yes, so the car is a small size. It's like creating wings for humans, isn't it? It is meant to be comfortable, convenient. It can take you wherever you want, on land, in the desert, in the forest, in the mountain, in the plain, across rivers, etc. So it's convenient. It takes you anywhere you want, and it's comfortable. You can spend hours driving a car, no problem. But it is less bulky than a train, for example. A train doesn't go. If you want to go to the Middle Atlas, there is no train. It stops in Meknes. So, right. In 1886, Carl Benz invented the first automobile run by an internal combustion engine. So, Carl Benz, a German man. So we must be thankful to the Germans for this. He was the first to create an internal combustion engine. This is what we're going to talk about later. And so it can be considered the first official modern car, 1886. 1911, the electric starter was invented. 1914, the car body was made of steel. And 1926, the steering system, direction. In 1935, the first flashing turning signals. So as you can see, the automobile is not one man-made. It was invented. It was invented, or it was a sum of many inventions. It was the focus of multiple inventions. Many people contributed to the development of the automobile as we know it today. 1939, the first air conditioning system. I didn't know that. 1939. So early. But it was developed much better later. 1970s, the airbag was added. But again, the airbag went through different phases until it became as efficient as it is today, as sensitive and efficient as it is today. 1985, airlock brake system in American cars. Well, something to do with a braking system that has to do with hydraulics, which are airtight, no air in them. 1995, the first American car makers offer automatic stability control, ce qui correspond à correcteur électronique de trajectoire, to give the car more stability. So the cars were first built to transport people and goods quickly and efficiently. This is the purpose. So this is the objective for the engineer is to help humanity achieve certain things. How people use it has yet to change as they used it back then. Um, they used it in the Great Depression, they used it in the First World War, and they still use it in their wars nowadays. It's a very important means of war. You can just have a look at what happened in Libya. Those Toyotas playing an important role. The car is built for the transportation of goods and people cross country throughout countries. The earlier car was obviously not built for long distance as it used to inhale a lot of gasoline, but modern cars are very fuel efficient. Yes, the earlier cars were very greedy. They were guzzling, but nowadays they are more efficient, and a lot of work has been done in this area. This is the class proper. This is a chapter I wanted to talk about. It was just an introduction. So, types and functions of engines and motors. The term engine usually refers to petrol engines, c'est-à-dire moteur à essence, diesel engines, and jet engines. The modern meaning of the word engine is used with petrol engines, diesel engines, electric engines, electric motors, and jet engines. In engineering, motor usually means electric motor. So كلمة engine and the word motor. Motor goes with electric, and engine goes with fossil fuel. We could say automobile as much as we can say motor car, but the word motor is interchangeable. Anyway, in engineering, motor is usually means electric motor, but in general language, motor can also refer to petrol and diesel engines. Engines and motors power or drive machines. They power machines by generating rotary motion, for example, to drive wheels. Yeah, this is the job of an engine or a motor, is to create rotary motion, and that will be transmitted to wheels to create movement. In jet engines, compressors and turbines rotate to generate thrust, pushing force produced by forcing shafts. Exactly. So le moteur à réaction. So it's a different system. So compressors and turbines rotate and they generate thrust. They push in the back. They push air in the back so that to push the airplane to front. How do we measure torque? And what is torque? We measure it in network meters. In Newton meters. As an engine produces a couple, rotary force, it's called a couple, rotary force, the moving parts of the machine it is driving will produce resistance due to friction and other forces. As a result, torque, the twisting force. Torque means the twisting force, the creating of the movement, the twisting movement, is exerted on the output shaft of the engine. Torque, calculated as a turning moment in Newton meters, is therefore a measure of how much rotation force an engine can exert. So torque is the twisting force, and that can be measured, and the unit for measurement of it is the Newton meters. And how do we measure engine power? We do measure it by watts or brake horsepower. The rate at which an engine can work to exert torque is the power of the engine, measured in watts. So the unit of measurement of the rate at which an engine works is measured in watts. Although engineers normally calculate engine power in watts, the power of vehicle engines is often given in brake horsepower, BHP, brake horsepower, puissance au frein. So we have to brake and to measure the power. Using a dynamometer, it refers to the available power of an engine assessed by measuring the force needed to brake it. So it should be at a certain stop, how to brake that stop, that stop. Horsepower is a historic measurement of the power of an engine's output shaft, measured in horsepower. Let us differentiate between certain words. British English petrol, ça veut dire l'essence, and American English, it's called gasoline, ماشي gasoil. Gasoline in American English means petrol, and British English, it's called petrol. Et le pétrole en français, petroleum. In British English, petrol engine. In American English, gasoline engine. Gas. Now let's move on to this gentleman whose picture you can see. We have spoken about Mr. Benz a while ago, the first to create the automobile. There is another German called Rudolf Christian Karl Diesel, who lived between 1858 and 1913. He was a German inventor and mechanical engineer, so he's an ancestor for you. He was famous for the invention of the diesel engine and for his suspicious death at sea. Well, that's none of our business. He was probably murdered. But anyway, you can read about that if you want. So he's very well known for inventing the diesel engine. And there was a film about him made in 1942. And of course, from there we can get the expression diesel fuel. In general, diesel fuel is any liquid fuel used in diesel engines whose fuel ignition takes place without any spark. Alors, spark, ça veut dire l'étincelle. On a besoin d'une bougie classique pour démarrer un moteur à essence. But in a diesel engine, you don't need a spark, a classic spark. As a result of compression of the inlet air mixture and then injection of fuel, the glow plugs, d'autres bougies, des bougies incandescentes, on les appelle bougies de préchauffage, grid heaters and block heaters help to achieve high temperature for combustion during engine startup in cold weather. So it's a different system for starting the engine. Instead of a spark, plug sparks, and there is there are glow plugs, and those glow plugs with the pressure of air plus the injection of the fuel, they start the diesel engine. So it's probably an easier and more practical, more economic system. Diesel engines have found broad use as a result of higher thermodynamic efficiency and thus fuel efficiency. This is why we find diesel in all heavy trucks and bulldozers, pillars and everything. So all of them are diesel. So thank you, Mr. Rudolf Christian Karl Diesel, for that. This is an engine seen from the outside. There is the cooling fan. The only role for the cooling fan is that it cools the engine. The engine heats a lot, so it must be made from materials that bear a high temperature. But even then, you need a cooling system and a cooling fan. As you can see, there is a cooling fan. There is a pulley here, and there are belt fans, and that belt is moving three things at the same time. The alternator plus the cooling fan. I would like to talk about this object here. It is called the oil pan. Oil pan. pan هي المقلة اللي كتعمر بالزيت فاش كنقليو الفريت، ولكن الطوموبيل حتى هي عندها المقلاة ديالها. It's where the oil is gathered at the bottom of the engine. So it is understandable that it should be named oil pan. And there is an oil draining plug from where the oil can be removed to be drained, asséché, enlevé, يعني vidange. كنديروا الفيدانج كنحلوا هاد البلاج هادي. All right, what else? The exhaust manifold. Exhaust c'est-à-dire l'échappement. Donc من هنا تيخرج الدخان ديال après l'explosion, après être utilisé. The spark plug cable. These are cables for the sparks. There should be four normally, four plugs. 1, 2, 3, 4. So there are four. Distributor cap. The vacuum diaphragm. Cylinder head cover. Cylinder head cover. So there are four cylinders at the bottom, and this is the cylinder head cover. Air conditioning compressor. So this is not an alternator. The alternator is on the other side, and this is the air conditioning compressor. So they are all used by one or several belts. So these are words for the parts of an engine. Here is an exploded view of the engine. You could see. I would like to begin from the bottom with the oil pan in here. The oil pan drain bolt. Where you pour la vidange. Drain bolt crush washer, c'est la bague what else? This is oil pan gasket. هاد الجوان هذا يتسمى gasket, oil pan gasket. Timing belt drive pulley. هذا timing belt, la chaîne, يسموها la chaîne. It's a pulley where a belt is to regulate the timing of the work of the pistons and the other components. This is the exhaust manifold that I mentioned a while ago, where the exhaust العادم what the used gas and smoke that can be expelled. It comes from the air. Exhaust manifold gasket, again gasket. There are many gaskets in an engine. They should be made of special material to endure. This is the, what is this? Engine block, sealant block. Engine block is this. Again, it's made of special material. The head gasket, another gasket. The cylinder head, joint culasse. What else? Rubber grommets, and then the cylinder head cover. Cylinder head cover. Cylinder head cover. Let's have a look at this here. Intake manifold. So there are 4 intake manifolds and 4 exhaust manifolds for orifices. Camshaft pulley. This is another pulley. All right. Okay. Water pump gasket. Water pump. Because you don't need just a fan to cool the engine. You also need a water pump. Which is circulated around the parts of the engine and taken to the radiator, which cools the water, and it's a circuit of water or anti-frost. There is an oil filter, water pump and oil filter. Okay, let me move on. This is a look more at the inside of the engine. The valves where the fuel comes into the cylinders. These are the pistons. 4 pistons, the crankshaft vilebrequin. This is the timing belt. Timing belt, واحد. And the alternator to produce electricity. The camshaft and crankshaft. شوف هذا سميته camshaft and this one crankshaft. This is a distributor. As you can see, it distributes at a regular time, at a specific time, to the various combustion chambers. So there are 4 wires or 4 tubes or pipes to the various combustion chambers. And this is a jet engine, as we said a while ago. The air which expels air from the back of the engine at high velocity and produces a thrust forward. So the air comes from here and it is pushed towards back with fans and the turbine system to produce a thrust forward. Internal combustion engines. Petrol and diesel engines are internal combustion engines. So there is a burning which takes place inside the engine. This means they are driven by combustion, by burning of fuel in enclosed sealed spaces called combustion chambers. I think this is a very clever thing to think of it in the first place. Somebody imagined how to burn fuel in an enclosed chamber to produce movement, to produce an explosion, and to exploit that explosion to produce movement. This is very ingenious indeed. In petrol and diesel engines, the combustion chambers are cylinders cylinders surrounded by a cylinder block and closed at the top by a cylinder head, as we have just seen in the picture. Each cylinder contains a piston. It's a very complex device, isn't it? It must have been very difficult to create and to make. The number of piston cylinders the number of piston cylinders in an engine varies. Engines in small motorcycles have only one. بحال 103 مثلا عنده piston واحد. While sports car engines may have 12, but ordinary cars have 4. Fuel is supplied to each cylinder from a tank. Tank هو reservoir. In most engines, the flow of fuel is generated by a pump. Pompe d'essence. So there is a pump which regulates the flow of petrol to the engine, which forces it at high pressure through fuel injectors. These vaporize the fuel, allowing it to mix with air. So there is an operation of vaporization of the fuel. It needs to become vapor, not liquid. It needs to mix with air to become sort of gas. Allowing it to mix with air, using this mixture of fuel and air, most engines function as 4-stroke engines. 4-stroke. It is called 4-stroke engines. This means they work on a cycle of 4 stages. 4-stroke engines بأربعة المراحل. حركة في 4 مراحل. This means they work on a cycle of 4 stages or 4 strokes. A stroke is an upward or downward movement of a piston. So a stroke is an upward or downward. So up and down plus 2 more. So the 4-stroke engine introduction or intake, compression, power or ignition, and exhaust. I don't need to go on through all that. Now let me move on to transmission of movement. And transmission is done through gears. Gears, ça veut dire les engrenages, les roues dentées, les embrayages. A set of toothed wheels, a gear is a set of toothed wheels that work together to alter the relation between the speed of a driving mechanism. So it's not enough to create an engine, an internal combustion engine. It's already a complex thing. You need to devise, to find a way how to transmit the movement from the engine to the wheels of the vehicle. So you need gears. Gears are very important, an important piece here. So they are a set of toothed wheels that work together to alter the relation between the speed of a driving mechanism, a mechanism which drives, such as the engine of a vehicle or the crank of a bicycle. So it's the same thing with a bicycle. The only difference is that the movement in a bicycle is created through a physical pressure on the pedal. Bien la manivelle comme dans cette canne à pêche. Hein? As in this fishing rod, as we shall see, it has gears as well to multiply and to transform movement. And the speed of the driven parts, the wheels. Yes, it's not just to transmit a constant movement, but to change its speeds as well. The gear wheels, they are wheels as well, aren't they? Or gears are wheels with teeth or cogs, we call them cogs as well. The teeth interlock, they fit together with those of other gear wheels. When one gear wheel revolves, the other revolves with it in the opposite direction as their teeth mesh together. The gears are normally fitted to shafts, like sticks. They transmit rotary motion from one shaft to another. That is, they transmit drive, they transmit movement. So an engine produces drive, and the gears transmit the movement through shafts. A shaft connected directly to an engine or motor is called drive shaft. The one which is fitted to the engine is called the drive shaft or an input shaft. So there are input shafts and output shafts. Drive shafts and follower. A gear wheel on a drive shaft is called a driver. To drive means to make something move, to push, to activate. A gear wheel on a drive shaft is called a driver. The second gear wheel, which meshes with the driver, is called a follower. So driver, follower. The driver drives the follower. Exactly. And it cannot be the opposite. An assembly of several shafts and gear wheels is called gear train. Gear train. Or transmission system. Transmission of movement. It begins with an input shaft and ends with an output shaft. I hope this is clear, this is understandable, and memorable, especially memorable. The system may contain idler gears, يعني هذوك اللي ما خدامينش غير كينقلوا ولكنهم ما تيحركوا intermediaries, that is, they are intermediary, I was going to say middlemen, middle gears. These change the direction of a follower. And they are very important, they are used to change the direction of a follower, because when a drive shaft turns in a direction, the follower turns in the other direction. But if you want the follower to go in the original direction, you need an idler gear. Like this. Here we have a driver which goes in the clockwise direction, but the follower is going in the counterclockwise direction. There's a shaft here and a shaft there to take the movement in that direction. However, here we have a driver clockwise, the idler in the opposite direction. However, the next follower, is going in the same direction as the direction of the drive shaft. Gear ratio, which means rapport de démultiplication. Gears can provide a mechanical advantage by using different gear ratios. That is not the same speed, not the same ratio of movement. In the diagrams above, the driver has 20 teeth and the follower has 60. Therefore, the driver rotates 3 times to make the follower rotate once. So the gear ratio is 3 to 1. 3 to 1. This means that if, for example, the input speed, that is the speed of the driver, is 3000 RPM, the output speed of the follower is 1000. It's a third the original. And of course, you can change that. You can change them by making the follower with a larger number of teeth or cogs, or with a smaller number of teeth or cogs, small in size. Okay, let's move on to talk about manual versus automatic gearbox. In some machines, a gearbox, la boîte à vitesse, is used to provide a number of different gear ratios. This is the job of the gearbox. La boîte à vitesse, 4 vitesses, 5 vitesses, 6 vitesses. So the gearbox is made of different gears of different sizes and numbers of teeth to create different ratios, and therefore you need a system to change from this ratio to the other. Therefore, the driver rotates 3 times, etc. So in some machines, a gearbox is used to provide a number of different gear ratios. A gearbox has a gear selection system, so you need to select. You have the gear stick, which allows you to change, which allows gears to be changed or shifted while the transmission is running. While the transmission is running, you don't need to stop to change, to stop the car to change gear. While still the transmission is going on, you can change gears smoothly. You can shift from one gear ratio to another smoothly without non-stop. This may be a manual gearbox. This is the classic one, which many people like, where gears are changed by a person, or an automatic gearbox, as in modern cars. It is automatic, which automatically selects a higher gear or lower gear as needed. Fishing rod reel. The reel ou le moulinet de la canne à pêche. As you can see, there are gears inside, and they allow the fisherman or woman to reel the fishing line quickly when fishing. When you get a fish, you can use this device using the pedal or the reel to move the line quickly and effortlessly. It's the same system in here. As you can see, the fisherman is using the reel and gears in them to deploy the line or to roll it in or to reel it in. Types of gear wheel. There are different types, as you will see. There are spur gears, engrenage cylindrique. You can bring them out in different shapes and forms depending on the function you want them to do. Spur gears, engrenage cylindrique, are the simplest gears. The teeth run straight across the wheel. But there are helical gears, engrenage hélicoïdaux, which have curved teeth so that they mesh together more smoothly. It was very smart to think of helical gears. And the bevel gears, engrenage conique, like a cone, allowing drive to be transmitted through an angle often 90 degrees. Extraordinary So all you need is to have strong, hard material to create gears to be able to transmit movement uh, um, in different directions and with the minimum loss of energy and with minimum loss of or with minimum resistance. There is another type of gear which is called the crown gear, engrenage de couronne, which also transmits drive through 90 degrees, often to a small gear called pinion, smaller gear called pinion. So the pinion is usually small and the crown gear is larger, and both transmit movement or drive at 90 degrees from one direction to the other. And finally, there are worm gears, engrenage à vis sans fin, and they transmit drive through an angle as well, through an angle. They also allow a low output speed relative to the input speed of the worm. They can provide a one-way drive, as a worm can drive a gear, but a gear cannot drive a worm. Now, it has one-way direction, or else the mechanism will lock. I've seen the system in an overhead projector, in a data show projector, which automatically, when started, raises from the surface to adjust towards the screen, and there is it has a worm gears mechanism, as we shall see in the picture. This is a worm gear mechanism. This is a gear, and this is the worm. C'est un vis sans fin. The bevel gear has a conical shape. As you can see, the pinion here has a conical shape, and this gear here has also a conical shape. This is a crown gear. It looks like a crown indeed, and here is the pinion, which is a straight, simple gear. Spur gear is direct, and this is a helical gear. As you can see, the teeth, or they are not straight. Spur gears, engrenage cylindrique, they are mounted in series on parallel shafts. So there should be a shaft here, a shaft here, a shaft there, and movement is moved from this here to there, to there, to there. I remember this in the old clocks. They contained gears, spur gears, arranged in this position, in this order, in order to create movement, different drive ratios, one for the minutes, one for the seconds, and one for the hours, probably. So, yeah. I hope this is a good example. Parallel shafts to achieve large gear reductions. Exactly. In those clocks, you don't have bevel or crown gears, because you needed movement only in one direction. Here are helical gears, engrenage hélicoïdaux, which have a smoother operation due to the angle twist, creating instant contact with the gear teeth. Probably they have a certain advantage to have them helical. So they have a smoother operation. These are helical gears, although they are on a parallel. The first one on a parallel shafts, but here these are bevel gears, but they are helical as well. Helical beaver gears. Two different configurations of bevel gears. This one is straight, and this other one is spiral or bevel. Spiral bevel gear. Now this one is also bevel because it's conical. This cross-section of the motor in this image demonstrates how spiral bevel gears of engrenage conic are used. So they are transforming or transmitting movement in different directions. 90 degrees. This is a better example perhaps, is using a conjunction of hypoid gears and spiral bevel gears to operate the motor. So the shaft here, the movement is like this, but this movement will go this way. This in the hypoid gear, engrenage hypoid, a type of helical spiral gear. The larger gear is called the crown, is a crown gear, while the small gear is called the pinion. This is an example of the worm gear, engrenage à vis sans fin. And these gears have inherent safety mechanism built in, ça veut dire intégré, to its design, since they cannot function in the reverse direction. هذا يمشي في اتجاه واحد، ما يمكنش يمشي في اتجاه الآخر لغرض ما. What materials are gears made of? Gears are made of carbon steel for structural machine usage. And their characteristics are the heat treatment applied, low carbon steel, high hardness obtained by carbonizing. So steel is the material or carbon steel. Gears can be made of non-ferrous metals, phosphor bronze casting, suitable for worm wheels, aluminum bronze casting. So phosphor bronze casting, a font, or aluminum bronze, kind of mixture of bronze and aluminum, used for worm wheels. Engineering plastics also heat treatments applied, used for injection molded gears, suitable for bulk production at low cost, applied for use with light load. And you may use that for. It depends what usage is. Is it heavy duty or is it something light load? So you can use plastics. You can use aluminum and bronze, and phosphor and bronze, and also rolled steel. Rolled steel, c'est l'acier laminé. Nodular graphite, cast iron, and stainless steel, with corrosion resistance against salty water, seawater, better than this reference. Thank you so much. These are the references. I hope you enjoyed that, and see you later in the next session. And last, we shall talk about automobiles. Thank you.